Any question so far? You hear me?
Yes, hello.
Hello, any questions so far?
No, it's pretty clear so far.
Oh, your name is Christopher, but how comes you use a account with name Matt? Oh, it's okay. Sometimes use different people's computer, it's okay. Or account. Anyway, this session is designed to answer the question or whatever request the student has. So if you have anything in mind you want to discuss, I will help you first. Otherwise, maybe go over some slides, but primarily is to help students. So any question or anything, any help needed?
Oh no, yeah, just I wasn't sure what the Friday meeting was for, but yeah, so far it's been pretty clear. I don't really have any questions so far.
Yeah, okay, that's fine. The teaching material, the lecture we pre-recorded, so you can look at the instructional section, right? Instruction material section that you can find in weekly in the weekly teaching material. You can actually watch the video there, and each video is maybe 2 hours or longer, so we can't repeat it here. Okay, it's too long, and there are a lot of things. This course was designed for 16 week. Actually, there is another 16-week session going on at Lewis right now. Okay, and your is accelerated half semester type of 8-week curriculum. So we take out some material, but still maybe 80% or 90% of the material still here. So I would say a little bit rushing because we actually put so much material into one tiny half semester. Yeah. So, but that's what I personally not a fan for this type of accelerated quarter or semester. It's really too short. I prefer a 16-week full semester. Yeah, but anyway, that's what we have so far, and the material that we teach so far. The chapter this week is supposed to be on lecture 3-4. But last week we go over the syllabus, but we did not go over the chapter 1. So chapter 1 basically talking about introduction to programming language, okay, and the compilation of programming languages. So chapter 1's main purpose is provide a overview of what is programming language. But this course is not to study any specific programming language or to teach you 20 programming language. That's not what this course is about. This course is about the interpretation mechanism that behind the programming language. So basically, primarily is on the language structure, why language are designed this way, not that way. So actually it's about design of programming language and the implementation of programming language compilers. Okay, that's what this course is about. So in the beginning, we talk about machine code, assembly, and high-level language. Okay, and the history of the language that actually is fine, and then different programming paradigms. We do have declarative, imperative, and imperative functional and object-oriented. These are three most popular computing paradigm right now, okay? So in the beginning, we talk about this, and then talk about these different paradigm and language, how the program can be interpreted. So basically, we have the pure compilation base, that's the C double plus, pure interpretation as Python language, and something in the middle that you do front end compilation, compile Java code to bytecode, and then back end bytecode to the machine code is actually using just-in-time interpreter. So this one is hybrid. partly compilation, partly interpretation. Okay, so that's the most popular languages, the way they are interpreted. Okay, so then talk about how interpretation is done in computer, and then finally talking about the structure of the compilers. Okay, and we have the 6 phase topic for these compilation stages. So that's chapter 1. Chapter 1 basically talk about different language and the different programming paradigm, the compilation schemes, and the different phases of the compilation. Okay, this is related to our course structure. Let's actually look at one more time. So that's the introduction of this book. And let's go back to our syllabus. So this course basic structure is this talk about fundamental of chapter 1. So chapter 2, 3, we are on data models, how variable being defined, and each language is a big memory model, how they are actually organized. Okay, that's chapter 2 and 3. Okay, and then chapter 4 start to do programming paradigm. So now let's look at the chapter 2 and 3. Okay, lecture 2 and 3, they are still within our purpose of discussion on the memory. So 2 and 3 are actually one combo. Okay, so chapter 2 is on data type and type system. So for any language, you do need to have variable. You do need to have storage of memories. And this one talk about the data type and type system. So here, data type, every language are different, but basically you are trying to support the quantitative and qualitative research. Okay, you try to support that. And then you need to support your program need to be able to support the data science workflow. Okay, collection of the raw data from the wall, and then process of cleansing the data, and then editing the data, and make sure that your data set is clean from your raw data, and then you feed into your machine learning model and using algorithm to do analysis. And then the analysis result, you actually try to make it visualization. So there's a data visualization stage. And that's the life cycle of the data science. Okay. Any questions so far?
No.
No? Okay. And that's the purpose of having the data type in programming language. Okay, so we are trying to actually process the data. Okay, so there's a type system. Primarily, we want to look at the different language. There are strong type language such as C#, Java. Okay, there are weak type languages such as JavaScript. So in JavaScript, you actually don't have the type. You have var type, and then the variable can be assigned with say var a equals 1, and then later you can assign it with var a equals string. So basically, JavaScript almost have no type, and they use the type in inference to determine the type at the runtime. Okay, so if a language do not have type, we call it weak type. If a language type actually is always being required, we call it strong type. Okay, if the language is type is determined at the runtime, we call it dynamic type, such as Python. Python do not need to declare type, but they do have a type. The data type is determined when the data being run. Okay, if the language type is actually declared at the compilation stage, we call it static type. So, for example, Java is static type. Okay, So the that's the different type system. And beyond the type system, we have primitive type and derived type and user-defined type. Okay, so these are different type in C++ language, and most of the other languages are similar, have a primitive type and object type or reference type. Okay, but C++ has the array, pointer, reference, and it is more complicated. Okay, C++ has pointer, separate pointer and the reference, not like Java. Java's pointer and reference are the same. So C++ is more complicated. But the machine, whatever Unix, Linux machine, even Windows machine right now, still being designed based on the non-numer model, and most of them are in C++ memory model. Okay, so in C++ language, and C language is the most closer language to the assembly and low-level language. Okay, it has a direct mapping of the memory HSMO. Okay. Okay. Anyway, here we also talk about cache memory, cache miss stuff, and we will talk about Python data type. So Python data type is runtime dynamic typing, and basically they are string, number, and Boolean, 3 type. Okay, only 3 type. And then they are extended type, okay, compound type, such as set, sequence, string, list, and tuple. Okay. And Python data type also very similar to JSON object. Okay. JSON object notation. We call it JSON. Okay. JavaScript object notation. Okay. So they are string, number, integer, number, real, Boolean array object. Okay, and this is mapping. If you want to load your Python language to JavaScript or JavaScript to Python. Okay, so JSON format is a glue between JavaScript and Python. If you are focused on the numbers computation, then you may use a NumPy SciPy package, and they are more data type in NumPy. Okay. Okay, next one, talk about the expression. So basically, talk about the operation of the variables, and then talking about naming system, and then talking about composite data type. Okay, I'm just going over to what chapter lecture 2 is talking about. Okay, so basically, primitive data type and compound data type, it covers these different material and string. Okay, and basically we go over the detail of how the different data have been declared and how they can be wrong. Okay, so here I don't waste time to repeat them, just give you the idea of what lecture 2 is. So let's move on to lecture 3. Okay, if no question, usually I'll go over the overview of the chapter. Okay, give you the idea of why material have been put over here. So after we know about the typing system, we want to know about how variable scope, binding, and the environment being work. Okay, in the system. So this is chapter 3, the Python reference environment. Okay. So Python reference environment, you can actually, if you are interested, you can go to the website. It's called pythontutor.com. Okay. So there's a website called pythontutor.com. So let's try in this one called pythontutor.com. Okay. So this pythontutor.com will teach you different languages, memory model. Okay. So for here, it had this sum, given an array of numbers, and then you start to calculate the sum, okay, in the list, whatever. But anyway, the right-hand side give you the stack diagram state calling frame, okay, and give you the idea of each instruction, how the call frame is, okay. So this one is a good reference of the memory model, okay. Any questions so far? Any questions so far?
No, thank you.
Okay, so that's actually a tool you can try. Okay, and I this down in the chat box, so you can actually look at it. Okay, so that's what we want to do here in chapter 3, that lecture 3. Okay, so lecture primarily talking about the definition of the name. Name is a variable's name, and sometimes it's for primitive data type, sometimes it's for reference data type, okay, sometimes for pointer. C++ has actual data type for pointer. And then these different variables may be associated with memory, we call it binding. And the lifetime of the binding, we call it scope. And then the scope of every variable, we call it environment. So this is the definition of name, binding, scope, and variable. Let me repeat one more time. Variable name is the name of a memory location, and the association of such a name with the location is called binding. But binding is not, sometimes it's there, sometimes it's not there, because you bind a variable with the memory location. Maybe the memory is stored in the stack, maybe stored in the dynamic memory. So it's not always there. So binding is like marriage. It's not 100% stable. So sometimes there is a divorce. Okay. So memory between memory and name also is like this. You maybe it's a local variable. After the stack being popped out, your binding will be gone. So there's a lifetime between the variable and the memory location and the variable name. So that's called scope. And the scope of every single variable that involved in the program is called an environment. Okay, so basically this one just talking about name, binding, scope, and environment, how they are handled. Okay. Okay, so here I give you the definition of name, scope, and binding, and I actually finished that. Okay, and there's a Python namespace. Namespace is a module. In C++ is also called namespace, but it's actually a module in other language. Okay, and in talking about lifetime and storage management. Okay, and garbage collection stuff. Okay. Okay, so there's a garbage collection we talk about here. And then talking about the scope and environment, okay? And when multiple environment happen, which one will be used to determine the result? But this portion has been binding to the Python language. It only discusses the feature of Python, okay? Okay, so this chapter primarily is on these different things, okay? So let's go to lecture 4. So lecture 4 is different from lecture 2, 3. It actually is the beginning of the imperative programming. So it's an independent chapter on one programming paradigm. And in our course, we teach 3 programming paradigms: imperative programming paradigm, functional programming paradigm, and object-oriented programming paradigm, okay? So let me see. Let me bring up the syllabus one more time. So basically, we teach 3 paradigms: imperative programming paradigm, functional programming paradigm, and object-oriented. Imperative paradigm is the traditional paradigm. Okay. It's using the if, then, else, and function call, and for loop, while loop, okay? Repetition, selection, and decision. So based on those functional programming idea, okay, strategical programming idea, we have the imperative programming. That's the first paradigm, okay? So we talk about different paradigms, and language was associated with the paradigm. Okay. And talking about why there is an imperative programming paradigm because of the Maneuver machine model. Okay. Okay, and this one is spatial programming. This part is traditional and simple. Okay. And the evaluation of the expressions. Okay, and then selection structure. These are traditional computing, so not that hard. And then iteration. And there's a part on the function code, okay, subroutine as well. Okay. And then talking about recursion and the layout structure. Okay. Okay, so this chapter primarily is on this. The calling sequence part is more difficult. About a prologue and parallel epilogue. Okay. You have to look at these two terms. It is tested in the quiz. Okay. Epilogue and prologue. Okay, any question today? I think I roughly go over the main idea of lecture 1 to 4. Okay. And the purpose is to give you the idea of why we put different chapters here. Okay. Other than that, I actually don't repeat teaching. Okay. Don't repeat the teaching material in the instructional material section. Here, I want to hear more about the question and try to answer. Okay. Any more question?
No, thank you for the review.
Okay. If no question, I'm going to call it for the day. Is that okay?
Yeah, I'll be back next week if I have any questions.
Yeah. Okay. Thank you. Okay. Bye-bye.